So this is the section on synthetic division. Synthetic division is kind of weird, but first off, we have what's called remainder theorem. Remainder theorem is pretty simple. It says if f of some constant is a 0, then x equals the constant is a 0 of the polynomial, and x minus c is a factor. All right, so we're going to see if these are factors of the polynomial. So first thing I'm going to do here, since x is 2, I'm going to find f of 2, and that's done by plugging in a 2. Oops, I forgot where I was. There we go. 2 to the third minus 8 times 2 plus 32. All right, so 2 to the fourth should be 16. 2 cubed is 8 times 4 is negative 32. We have a minus of 16 there and plus 32. And you can kind of see that the 16 is not, and I know most of you guys are just going to push buttons in the calculator without using that God-given brain of yours, but everything worked out, didn't it? So it turns out that f of 2 is equal to 0. So by remainder theorem, x equals 2 is a 0, and the factor is x minus 2. Now, I've got 4 mentioned, but I'm going to do 3 instead. I'm going to find f of negative 1. So that's a negative 1 to the 4th power minus 4 times a negative 1 that is cubed minus 8 times a negative 1 plus 32. And let's see here. If we take a negative and we raise it to an even exponent, we get a 1. We get a positive. This one's going to be negative 4 times negative 1, which I'll clean up. That's going to be plus 8, and that's going to be plus 32. Now, we have 1 plus 4 plus 8 plus 32. It turns out f of negative 1 is 45. So what did I learn? X equals negative 1 is not a 0, which means that x plus 1 is not a factor. All right, you guys get to do 2 and 4. Now I'm going to move on to my life. So I'm going to look at number 5, and this is synthetic division, which for some reasons bothers the heck out of kids. Synthetic division is a special case that you can only use when dividing by a linear factor. So I had an honors group years ago that we actually derived synthetic division, but that's been so many years, I probably couldn't even do it now. Anyway, synthetic division only works when dividing by linear, we'll say factors, because we're hoping they are. Now, linear, when I think linear, I'm thinking mx plus b if you live in America, things that look like lines, okay? So this is my supposed factor. X plus 3 might be a factor, which means that x is negative 3. And that's what gets kids so many times. They just want to, I don't know why kids struggle with sign changes, but boy, they do. But if I'm dividing by x plus 3, I'm going to have a negative 3 out front. And the acronym I teach here is DMA. Drop, multiply, ran out of room, and then add. All right, we're going to load up our coefficients in our vinculum. 1, 3, negative 16, 48. We're going to drop the first one, an emphasis here on the MA. Then we multiply. 1 times negative 3 is negative 3. And then we add, we get a 0. Then we multiply. Negative 3 times 0 is 0. And then we add, we get negative 16. And negative 3 times negative 16 is 48. Something's wrong with this problem. I'm not supposed to be getting 48. think that's supposed to be a plus 16. I'll fix that on your piece of paper. There's my 0. Anyways, let me go back and fix that. Before I forget. Sorry about the time I'm wasting here. All right, now I want you to completely factor it. I'm going to take this a step past Algebra 2. But this is your remainder, this is your constant, this is your x, and this is your x squared. At least it's a step past what Algebra 2 now is in the great state of Tennessee. And I say that sarcastically because they have neutered Algebra 2. What's left is x squared plus 16, which normally you don't think factors, but it actually does factor. And I wish we would push this more and more. But let's take x squared plus 16 and let's set it equal to 0. We're going to move that 16 over. We're going to counteract the square with the square root. And we know it's imaginary, so it's the imaginary root of 16. And the root of 16 is 4, so plus or minus 4i. Turns out that does factor over the complex number system. It factors as x minus 4i and x plus 4i, because you can just take those things and plug them in. Right? There you go. She's completely factored. All right, what's up next? Number 8. I would be amazed if this worked out. Do remember you're dividing by x plus 4. So x is negative 4. That's the, sorry, dividing by x minus 4, so x is positive 4, if I can think today. Coefficients here are a 1, a negative 5, and you're going to need a placeholder because there is no x present. Placeholder gets kids all day long. Anyways, the acronym here again was DMA. Repeater on the MA. We drop the 1, we multiply and get 4, we add and get negative 1, we multiply and get negative 4, we add and get negative 4, we multiply and get negative 16, we add and get negative 18. This is my remainder. The remainder is preceded by a constant, which is preceded by an x, which is preceded by an x squared. So it turns out that x cubed minus 5x squared minus 2 sitting pretty over x minus 4 is equal to x squared minus x minus 4. Take away 18 pieces of x minus 4. It's not that hard, but it's also new to you today. Given a polynomial f of x and a factor of f of x, factor f of x completely, and it says there the divisor is not simple. It's not x minus a constant. Use your long division. So this is the previous day's lesson. Going to throw x squared minus 3. You know, I run into a lot of kids who just would rather do long division. The problem with long division is she's long. X to the 5th plus 0x to the 4th, you need your placeholder, minus 3x cubed minus x squared plus 3. Now, to turn an x squared into an x to the 5th, I'm going to need an x cubed. Then I invoke the distributive property, x to the 5th minus 3x cubed. I'm going to wrap before I subtract. If you don't wrap, you'll have lots of problems in this life. A negative, take away a negative's addition, so there's nothing here. There's nothing there. All right. I'm going to drop down the negative x squared plus the 3. And to turn x squared into a negative x squared, I need a negative 1. That's going to give me negative x squared plus 3. Wrap before I subtract negative 0. So what do I know so far? I know that x to the 5th minus 3x squared minus x squared plus 3 is equivalent to x squared minus 3 times x cubed minus 1. That's what I know so far. Now, let's kind of use the gist of the zero product property. X squared minus 3 is nothing. X squared is 3. X is plus or minus root 3. So this piece becomes x minus root 3 and x plus root 3. This guy, that guy right there is special. X cubed minus 1 is an a cubed minus a b cubed pattern. So a cubed minus b cubed factors is a minus b. You guys have this acronym SOAP for your signs. A squared, same right there. Opposite plus, opposite of a negative is a positive. A times b, and then the AP is always positive, b squared. So if I realize it's an a cubed minus a b cubed, it takes an x cubed to create x cubed, and it takes a 1 cubed to create the 1. So a is x, b is 1, x minus 1, x squared, plus 1 times x is x, plus 1 squared, which is 1. So that I'm going to insert right down there. X minus 1 times x squared plus x plus 1. And the second piece, you're never going to be able to do anything other than pull a number out of it. So just consider it factored. It is 99 100 times. All right, next one I got highlighted is number 11. You're given a 0, factor it completely. So this is literally saying x is 7. I don't have to change its sign. In synthetic division, I throw a 7 out front. I keep the coefficients only. And then again, the acronym here is DMA, drop, multiply, and add. So we're going to drop that 10. 7 times 10 is 70. Negative 81 and 70 is negative 11. 7 times negative 11 is negative 77. 71 minus 77, or 71 plus a negative 77, is negative 6. 7 times negative 6 is negative 42. Got my remainder of 0. Again, we have a remainder, we have a constant, we have an x, we have an x squared. So I'm thinking 10x squared minus 11x minus 6 is a nothing. Now, this guy, you can either factor or you can QF. Your lesser students are going to use a quadratic formula. That's just the way it is. And I don't even say, that sounds so mean when I say it. But you have students who cannot factor, and they're going to do the quadratic formula because it makes them feel warm and fuzzy. That's why they're going to do it. So I'm going to factor as I think it factors. Let's just try it. I'm going to go with 5x and 2x. And if I'm wrong, I'll try again. Factors of 6 are probably 2 and 3. And I like that. It looks right to me. The outside's going to make 15x, and the inside's going to make 4x, and the goal is at negative 11. So minus the 15, add the 4, done. Now, your job was to factor it completely, right? So I have this, and I have that. X equals 7 is a 0. The factor is x minus 7. X minus 7 was the given factor. Then we did some more factoring because factoring is our favorite F word. That is the complete factorization of the given polynomial. I have 12 highlighted. All right, so you are given expression for the volume of the rectangular prism. Find an expression for the missing dimension. So I know that this is a factor. And so is this. This factor says x is 1. This factor says x is negative 6. I can do synthetic division. And I'm going to start with the 1 because it's smaller. My coefficients are 1, 13, 34. And this is a Milbrath original problem. This is not something I pulled from a textbook or anything. This is a Milbrath original. And I'm going to drop. I'm going to multiply, and I'm going to add. I'm going to multiply, and I'm going to add. I'm going to multiply, and I'm going to add and get a 0. Now, because And only because the remainder is 0, I can use the new numbers. Only because that remainder is 0. So this time we're going to drop down. We're going to use the -6. We drop, we multiply, and we add. We multiply, and we add. Remainder, constant x. This is x plus 8, which is the missing piece. It is. It turns out that x plus 8 times x minus 1 times x plus 6 is in fact x cubed plus 13x to the second plus 34x minus 48. I think there's only one more of these I'm going to do. It's 15. It's the only one I've got selected. Given x squared minus 1 is a factor of 12x cubed plus blah, 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 find all solutions of g and completely factor. It says, hint, x squared minus 1 factors. X squared minus 1 is a dots. It's an a squared minus a b squared pattern, which factors as a plus b times a minus b, which means that x squared minus 1 factors as x plus 1 times x minus 1, which means I can do synthetic division because these are linear factors. I'm going to start with the x plus 1, so I'm going to put a -1 out front. My coefficients are 12, 3, -12, -3. I'm going to drop. I'm going to multiply. I'm going to add. I'm going to multiply. I'm going to add. I'm going to multiply. I'm going to add. And because I got a 0, just like on the previous example, this time I can shift over and I can use the same numbers again. The factor is x minus 1, which means the x value is 1. I'm going to drop, I'm going to multiply, I'm going to add, I'm going to multiply, I'm going to add. Remainder, constant, x. I am left with 12x plus 3. I'm not trying to find zeros, I'm trying to factor. Both of these pieces contain a 3. It's 3 times x plus 4. So the complete factorization is 3 times x plus 4. Plus these two factors that were previously found, x plus 1 times x minus 1. And again, do not blindly copy. And also, don't give away your homework. Don't do this. You ain't doing any one of us either good. I need you to grow so that you can comprehend what comes next. I don't need you to be stagnant. I don't need you to get dumber. I need you to grow. And that's it. So there's your synthetic division homework. I hope you like synthetic division. I do.